Okay. So my screen is visible, right?
Yes.
So let me give the NTEM overview. So NTEM question is done. NTEM. So there will be five true false question, like approach, like we are talking about, and there will be 15. Most of the will be NAT question, MCQ, and MSQ question. Among 15 NAT, like 15, this 15 will divide into three parts. First will be combination. Combination, this will be five question, week 1 to 4. Then there will be sequential. There will be five question. And here processor design. There will be five question. So 15 into 3 equal to 45. All of them will be 3 marks. And 5 into 1, it will be 50 marks. So according to that, you can prepare sequence. You can prepare NTEM.
So this 50 marks question paper will be capped to 40.
This 50 marks.
Question paper will be capped to 40 marks.
No, no. This is 50, right? It will be like converted to the 100, and whatever the NTEM is
Okay.
there. That will.
NTEM contributes to 40 marks.
Yeah. So we'll generally convert to the 100, then we'll take 40%.
Okay.
So the NTEM question will be like, if you're able to solve, I'll suggest like try the previous year question and all the PA, GA question. That will be sufficient for NTEM. So you have to solve more and more problem. Okay.
20, so around 20 to 22 questions will be there.
No, no. 20 question will be there.
Okay. And 1.5 hours. Okay.
Yeah, 20 question will be there. 15 NAT, MSQ, and MCQ and MSQ will be there. So NAT, most of the question will be NAT. Well, around 12 is, I think, there among 15 NAT questions. And other than that, is MCQ and MSQ will be there. And five true false question will be there. This is the true false question. True false question. So I think in like similar like quiz to whatever the true false question. Okay, so hi, good evening, afternoon. Am I audible, right?
Yes, yes, you are.
Okay, I think afternoon was in the mood. Okay, so let's design some of the thing like counters, some of the design, like some of the counters. Let's design, then it will be good. So first question is, we want to implement a circuit. The output changes in the sequence. So how many of you watched week 9 lectures?
Good evening, sir. I hope I'm audible now. I think my
Yeah.
mic are not working. Sorry about that. Yeah. No, sir. I have not started the week 9 yet. Just to,
Okay, so I think this Sunday is the deadline, right?
yeah, yeah, definitely. So we'll be doing that.
Yeah. So okay, so let me like we'll do using the deep flip flop first. Then we'll after that we'll do using the JK flip flop. That will be good, right? So we want to implement a circuit where the output changes in the sequence 0001 to 0011, then to 1100 to 0101. First is the what is the minimum numbers of, let's, this is a D. Suppose first will D. D flip flop required to implement the above counters, assuming all the basic gates are available. So first question is like, how many D flip flop required? How many D flip flop is required? So you have to see the numbers of unique states. You can see that there are four unique states is there. So it will be log 2 4. So there will be two D flip flop or two JK flip flop required.
So that 4 is the number of bits, right, sir?
Numbers of unique states.
Oh, unique states, is it? Okay,
Yeah,
sure, sure.
yeah. So this is the
Something
number.
like MUX concept.
Yeah. So numbers of unique states is required. So you can see that one state is
And
there,
there
two state.
also in encoder decoder we had this logic, no? Log
No,
and
no encoder, no decoder. So,
no, no, I was referring to the week 4 content somewhere it was like that.
Okay,
okay.
over 2, right? That K and we have to keep dividing it again and again. Is that what you are
No,
referring to, Bimlesh? I think.
Yes, yes, I mean, so suppose there is an input
Hmm.
and there was number of outputs, so that output was like log n to the base 2
yeah. That is like multiplexer.
multiplexing.
Okay,
Correct.
Yeah.
okay, okay.
So two D flip flop required. So now question is how you can design that these things. So first, what we'll do using the 2D flip flop, like you can design counter like 00 to 01 to 10 to 11 using 2D flip flop, right? We can design. Suppose
Yes.
Yes, sir, we can. Yeah.
yeah, suppose this is the D. This is the suppose clock. Another D. This is Q1, and suppose this is another D1 flip flop. This is D2 flip flop. So this will be the Q2, and this is the clock. So we can design this and these things 00 to 01 to 10 to 11. Correct.
Yes.
Now what we'll do, we'll map to that whatever the current. So what we'll do, so 00 will map to the 0001. 01 will map to the 0011. Then 10 will map to 1100, and 11 will map to the 0101. Then we can design the like whatever the required counter, right? Up to that is correct.
Why this particular, I mean, selection?
Because if you want to design then like that, it will require 4D flip flop, right? So we will map to the using 2D flip flop. We can design
No,
like that, right?
that I understood. But then why this? How you are able to come up with this particular combination? Why
So
not
we
something?
can you can map to anyone, right? 00 we can map to 001 also, like whatever the above sequence is that just I'm mapping
Okay,
zero
so
zero.
okay, so we have been given four sequence. So anything you are mapping to
Yeah,
anything.
yeah. So
Okay.
now let's design that circuit. Okay, first will be let's 00 to 01, then 10 to 11, right? So initial uh, input, then the final output, right? Like next state, and out the D1 and D2. So Q1, Q2, Q1 next, Q2 next. This is D1 and D2. So first is 00 to 01, 01 to 10, then 10 to 11, 11 to 00. Up to that is correct. This diagram is correct. Initial state. Any doubt?
It's clear.
Okay, so what will be the D1? Can you see? Suppose you want to 0 to 0. What will be the D1?
It should be 0, sir, right? Because it copies.
Yeah, it will be 0. Then it will be 1.
One.
It will be 1, and this will be 0, right?
Hmm.
Okay. Now, what will be that? This
1 0 1 0.
1 0 1 0, right? So, what will be the value of D1 if you take SOP?
It's a XOR, sir, right? Because if it is 0 0, it is 0. If it is 1 1, it is 0.
Okay.
Only if it is 0 1 and 1 0, it is 1. So that is like XOR,
Q1 or Q2,
right?
and what will be D2?
Uh,
You have to take SOP of this and this, like this and this. So, what will be D2?
right.
Q2
So it
dot.
will be Q2 not Q1 not Q2 not Q1 Q2 not.
So, Q1 not, Q2 not plus Q1,
Q2 not.
Q2 not. So, you can take Q2 not common, right?
Right, sir.
Q2 not on.
So, it will be Q2 not, right? Okay, now let's design the circuit in the logic in the circuit bus. So, let me stop my screen. 1 second. One second. Okay, so let me share my screen. Am I audible, right? My voice is clear.
Yes, yes. Yes.
Go to circuit bus. Circuit bus. So what will require first is you have to D1 and D2. So close. So you can see a sequential element. So you can see that this is a D flip flop. So drag and this. So this is okay. So this is D flip flop. So we'll look at two D flip flop. So two D flip flop, right? And remember, this is D1 and this is D2. So first is like D1 equal to Q1 or Q2. So let another gets. So this is the JOR get, right? So let right left. So this is the Q1. So put like that, right? And like that. Like that. Right? So this will be and D2 is equal to Q2 bar, right? So D2 equal to Q2 bar. This is Q2 bar skip to bar. Now we have to put the clock, right? So we can see that CLOC type clock. So it will get. So initially we'll do enable not enable. So then we'll give the clock, right? So and for displaying the output, we'll use output here. There will be output. So you can see you can attach to that. Yeah, you can attach like that. Then another attach like that. Okay. Now, okay, what happened? So now let's put the clock pulse. So you can see that 00, it will convert into the 01. Then after that, you can see that 10. Then after that, it will 11. After that, it will 00. So if you do the clock enable, so you can see that the clock enable. So you can see that it is like changing from like that. Up to that is clear for everyone.
Yes, sir. I have one question here, specifically
Yeah.
regarding circuit was. So, like in this case, the clock is enabled, so it is like repeatedly changing the states. Now,
Okay.
how do we keep track of which state number it is, right? Because if it is running like this, we don't know where it started and
Okay. So just suppose you want to do like that, then you can do off the clock enable and you can put clock, right? Now it's 10, right? Now after that, put clock pulse. You can see that 11. Then after that, it will
okay,
00. Then put clock
mhm,
pulse. It will be 01. So you can
okay.
kind
Keep
then and
track like that.
you can also like increase the clock pulse. So if you want to increase, you can give 2000 also, right? So it will be like kind of slow, kind of that. So you can see that changing slowly 0
Mm,
0,
mm,
then 0 1, then 0, kind of that.
okay.
So up to that is clear. Now we have to map, right? So let's map that. Okay. Now let's go to iPad. CR. So we have got the. So now we have to map, right? So you can see that. So we'll just remove here. Hmm. My voice is audible, right?
Yes, sir.
Yes.
Okay. So suppose this is a Q1 and this is a Q2. So kind of that. Right. And suppose this is a, this is a B, this is a C, and this is a D. Right. ABC, and this is a D, right? So we'll map to 0, 0, 2, 0, 0, 0, 1, 0, 1, 2, 0, 0, 1, 1, then 1, 0, 2, 1, 1, 0, 0, 0, sorry, then 1, 1, 2, 0, 1, 0, 1, right? Now we have mapped, right? Now what will be the value of A if you take S of P? A will be, if you take S of P, then it will be Q1,
K2 bar.
Q2 bar. What will be the value of B? Value of B. Value of B will be Q1.
Yes.
What will be the value of C?
Q1 bar.
Q1 bar Q2. And what will be the value of D?
Q1 bar.
Value of D. You have to take 3 combination, right? So you can take like uh,
Q1 bar.
Q1 bar it will be there.
Oh,
Because there are
one.
3.
Three is also there. Okay.
Okay, so you can take. So this will be 0, this will be 1, this will be 0, this will be 1. So 0, 0, it's 1. Then 0, 1, 0, 1, it's 1. And 1, 1, it's there. So this is suppose this is Q1, this is suppose Q2. Again, one combination and another combination. This will be
Q2.
Q2, and this will be
Q1 bar Q2.
Q1 bar, right? So
Q
Q.
bar one. Q1
Huh?
Q2. Yes.
Okay, now let's do in the circuit verse. Up to that is like everyone understand like how we getting that all the things. Okay, now let's go to say circuit verse. Okay, so entire screen. So A equal to Q1, Q2, right? And get, right? So what will do? Put and gets and gets. So A is Q1 and Q2, right? So it will be Q1 and Q2 bar. Q2 bar is there, right? So it will, you can take here. This is Q2 bar, so you can take directly here, and this will be the A, right? So you can take outputs. You can just take this will be right. This will be up. Sorry, orientation up. So I can take this is the A. You can level also, right? And what is the B? B equal to Q1, right? So B equal to this is Q1. So B equal to we can take. So we can take this is B. This is B. You can take. And what is C? C is again Q1 bar Q2, right? So I can take another gets. This is Q1 bar Q2. So I can take this Q1 and you have to take Q2, right? So it will be this will be C. What is D? D is Q2 plus Q1 bar, right? So this is OR get. This is OR get. This is Q2 plus Q1 bar, right? So Q2 plus Q1 bar. So you can take here q q2 plus q1 bar, right? So from that we can take q1 bar, and this will be your d, right? So it will be d, right? So now let's check what is the first is 0001. So you can say the 001, then it will count 0011, then it will be 1100, then it will be 0101. It will be 01. This is clear for everyone, like how to build kind of that, like build this type of counter. You can try also using circuit bus, like
Yeah, but we tried doing with 2 DK flip flop,
yeah,
and that was through log 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 42.
yeah,
So log
log
42 gave us like with 2 we can do, and then we tried designing this.
yes, correct. Okay, suppose you okay, let me one question, like suppose you want to design how can I say that, 3-bit like even counter or odd counter. Anyone like how to design? Suppose you want to design, so let me that notepad. So what is meant by 3-bit odd up counter? So 3-bit odd up counter means like this is first, like 001 is odd, then 011 again odd, then after that 3, then 5, then like 101. It is again then after that 5, 7, 7 is 111, right?
Okay, so basically these are the outputs.
Yeah, these are the output, and another is 9. 9 means
4
so it will be 1001. So how many flip flop is required?
there are
How many
1,
flip
2, 3, so 5 states are there.
so how many flip flop are required?
4, 5, 3.
Sorry, 3-bit, only 3-bit is there, right? So this 1001 is 4-bit, right? So oh yeah, sorry, up to that will be there. So how many flip flop will be required?
2 again, 4 states.
Okay, so can you design?
You can
Let's design this circuit again, is unique flip flop. So we have already have a, like we have designed 00 to 01 to 10 to 11. Now we have to map, right? So we want to map to 00 to suppose 0001, then 01 to 011, then suppose you want to map to 10 to 101, and suppose map to 11 to 111. So what is the value of A, B and C? Okay, let's here come to here. So share screen. So we want to map 00 to, okay, let me 00 to 001, 0 1 2 0 1 1 and 1 0 2 1 0 1 then 1 1 2 1 1 1. Right, suppose this is the q1 and this is the q2. What will be the value of a, b and c? What will be the value of a?
A will be just Q1.
Yeah, a will be q1. What will be the b?
B here will be Q2.
B will be q2. Yeah, b will be q2 and c will be 1, right? Because all the things is there, so c will be 1, right? Up to that is clear.
Yes, sir.
Okay, so let's then come to circuit bus. So let's copy that circuit. Control C. 3 8 all of counter.
So again, we gave the 0001 those outputs.
You will delete.
We map to different combinations.
Yeah, correct. So let's
So
delete.
now we are just making changes in this.
So let's delete that circuit, like those not required.
நெக்ஸ்ட் வீக் வந்து முடிஞ்சிருச்சு. அதுக்கு அடுத்து ஒரு வீக் தான் இருக்கு. மண்டே அன்னைக்கு வந்து ரெக்கார்ட் பண்ணணும்.
So this is 2-bit counter, right? So let's a equal to q1, right? So a equal to q1, a equal to q1. So just you have to give the q1. So you have to give the output properties. This will be off. This is a. Then b equal to q2. So control C, control V. This will be b, right? B and c equal to 1, right? So you have to give the c equal to 1. Input title and college give 1. So you can see that 001, then 0111, then 101. So everyone understand how to build their this type of counter. You can also build using the 3 flip-flops, but it will, like, you can see that one extra flip-flop will be required. Using 2 flip-flop we can build, right? Okay.
Yeah, but one constant input of 1 is
Yeah.
required for C.
Yeah, it is. In this case, like here, it will like recur one constant because last bit is one, right? For odd half counter, right? And for even counter, it will recur 0.
Yes, basically last bit is not changing at all.
Yeah, you can see that. See, we
Yeah,
recur.
last LSB is always 1.
Yeah, yeah. Okay. So I'll suggest like all the practice assignment questions and all the graded assignment questions. Try to simulate in the circuit bus or any simulation that will help your understanding. Yeah. So any doubt? Otherwise, we will wind the session.
Sir, could you please share the session
Yeah.
live? Will you please share the recording?
Yeah, we'll share the recording. Maybe like
Oh,
after the session, we'll upload to the YouTube and we'll share.
okay, sir.
Okay, then. Thanks, Viblan. Then thanks, Pras. Thanks for joining.
Thank
Thank
you.
you. Sir.
Good night, everyone.
Good night.
Good night, sir.